inequalities. I don't really go past that because then it's gets a little crazy. But it does say 3 or more, so some of the homework questions may have more than 3. Okay. Same as before, guys, just more work, basically. Be careful when selecting the POIs. There you're going to have to be careful. It has to surround the solution region. That's where I'm going to highlight things. Careful when selecting POIs. It has to surround the solution region. Because some students start just finding all intersections and just slap them in the answer. It's like hope for the best, right? Find your solution region, and it's the points that surround it that are the POIs. It is a good idea to graph all lines on the calculator before graphing on paper. Same as before, since the POIs might be outside the grid if you don't do so, right? You just start, oh yeah, I have my intercepts. You go start graphing, all of a sudden, wait a minute, like they meet like way out here somewhere on your grid. So you need to readjust your scale. Okay? Doesn't happen very often, but it does from time to time. So let's get going. And I have some challenging ones in here. This one is pretty straightforward. What do you notice about this one? We talked about that yesterday. No constant. You see that? There's no like number on its own. It's 0, but other than that, we don't see it. So this is the one where you have to make up your extra point. Okay, you have to make up. And this one is just a vertical line. So this one is very easy. Okay, so that's usually what I do. I probably mix in at least one vertical or horizontal, and then 2 other ones that are diagonal. Okay, but it really varies greatly. Okay, let's do this one first. I want to make it look like the standard form, so the 4y comes over, and try to mimic the way I use my space. Otherwise, you're going to be in trouble. So 4 comes over, and you're left with -12. Do not forget about your signs. Okay. Let me zoom into that one so you don't have to. Your eyes won't hurt as much. Hold on. You can do it, camera. I don't want to. There we go. There. So x-intercepts, y-intercepts. And you don't have to show me a ton of work, but make sure it's neat, okay? Neatness is something that I would stress, because otherwise you yourself sometimes pick the wrong number, okay? So don't lose the marks there, it's frustrating. So here we go, 3x is equal to -12 because the y turns into 0, so I'm just left with that. And remember, here we're just dealing with the boundary line for a little bit. So x is equal to -4. That's -4, 0. All right, y-intercept. -4y is equal to -12. You divide both sides by -4, right? Y is equal to 3 positive. So that's 0, 3. All right. Rewrite it. So I'm taking the one I already started to rewrite, and I just want to leave for y on its own, but like y on its own, right? That's my ultimate goal. 3x comes over past this, subtracting, and the -12 is already there. Divide by -4. Flip, right? So y, instead of that way, it's going to point the other way. And that's 3/4x minus +3 plus 3. Okay, jags there. Dashed. True is above. And now I hope you're starting to see why I do this every time. Why I tell myself this right off the bat, because once you start graphing, it's easy to just go and find that right there. Okay. So this is what you started with, just one. Now I'm doing 3 at a time, right? Let's do the next one. No, I'm going to write above it here, no constant. Okay, there's no constant for that one, but not to fear, we'll tackle it, right? So rewrite, what I will do is rewrite immediately. So I'm going to divide both sides by 4 because it's already how I want it. So y is less than, you don't have to flip it because you're not dividing by negative, negative 3 over 4 x. That is my equation, or my inequality, but the boundary line is the same, right? It's just an equal sign there. You can pick whatever you want for x, but there's a smart pick and there's a pick that isn't so smart. In this case, you see this denominator of 4 here? I'm going to let x be equal 4 or a multiple of 4. You could pick 8, you could pick whatever. I'm going to pick 4. So I will say this. I've done it multiple ways, but I think I'm going to start this way. Let x equal to 4. I will say smart pick. I don't know. Does that make sense? So second point will be y is equal to negative 3 over 4 times 4, right? I let x be 4, and that cancels out. So that leaves you with negative 3. So what you've just done is you said that if x is equal to 4, y is equal to negative 3. Okay. It doesn't happen very often, but these ones you have to pick a number. And let me tell you this, no constant. So first point is what? What's the first point that is there for sure? 0, 0. That is a guarantee. If you were to do x-intercept, y-intercept, if you were actually going through the motions of doing this, both of them would give you 0, 0. That's why don't bother with it. It takes up way too much time and space. So first point, second point. Okay, but I can already tell myself here, this is going to be dashed. True is below. Slow it down, Mr. Dirksen. Shading goes above. Just there we go. So I think I'm going to box this in. This is sort of the extra step required. Instead of finding the intercepts, this is sort of the extra step required to find that second point you need to in order to graph this thing. Mr. Erickson, could I have picked 100? Yes, you could have. Could have picked 100 for x. Negative 3 times 100, that's 300. And then divided by 4, and whatever you get there, that would be your other point. But it's not the wisest to do so. Okay. Let's keep going. This one you should all be familiar with. Special case. I don't think, yeah. Sometimes there will not be a special case. So, and sometimes the special case only arises once you clean things up. Okay, the x's cancel out. Only left with y. Okay, that's a horizontal line, right? So this is a vertical line. So vertical line goes through and negative 4, 0, right? So we know that this is solid. True region is, it's greater than, right? X is greater than, so true region is to the right. I hope you have some kind of table on your study sheet to help you out with that. I will shade left. I will shade the opposite of where the true region is because it makes it easier when you do a system. So I don't know, I'm going to circle all of these here because there's so many of them, right? So now we're ready to graph. You're excited? Not really, right? Okay. So let me see if I can keep most of it on there and sketch at the same time. 35, page 35. Okay, here we go. Will 5 in each, 10 in each direction be sufficient? Let's graph this. Oh, I think this is very interesting. Did I show you how to graph a vertical line? The cheat for vertical, the 99999. I didn't. Okay. Okay, I have to show you that. That's pretty cool. So we're gonna go to y equals and type in your rewritten. You should do that because it's gonna be interesting to find the POIs here. Okay. That's why I made you do the initial review of systems, right? Where you have multiple points of intersections. So that's my y1. My y2 is this one, negative 3 over 4x. And then this one. I will have to add this to your notes before I do this, okay? This is a cheat to graph vertical because this calculator does not allow vertical, technically, but I found a cheat on YouTube. We go like this. We'll make y3 equal to, you have to type in 9 nines. That's easy to remember. 9 nines followed by a bracket where you go x and you use the opposite sign of what you have for x. So if it's negative 4, you need to enter positive 4. Let me zoom into that and just say that we're going to put an arrow to that plus and just say opposite sign. This is a cheat. I've never, you're probably the second group that I've used this with. I find it pretty cool. It solves a lot of problems. So here we go. 1, 2, 3, 1, 2, 3, 1, 2, 3. Then bracket x plus 4 because it's the opposite sign. And then let's hit graph here. Boom, boom. And there's my vertical line, which is at negative 4, you see, right? You can confirm. This will work just fine. All the lines are intersecting within my 10 by 10 grid. So let's go ahead and graph this now. These are actually your 5s here. Okay, and one at a time. So negative 4, 0, 0, 3. That is a dash true above, right? But the true part I'm going to do later. The shading I do at the end. So I just go all the way to the end of this grid. I label it, then I do the next one, which is 0, 0, and then it's 4, -3. By the way, could we have predicted that this is the case? What's the slope of this line? It's 1, 2, 3 drop, and 1, 2, 3, 4 run. -3, 4, right? So that's another way you can confirm. This is also dashed. I'm going to label that here. And the last one, which is fairly easy to do, goes through -4 right here. And it happens to already be a point, an x-intercept for the first line we graphed, but this is a solid line here. And this is the line x, or the inequality x is greater than or equal to -4. All right, don't find the points of intersection yet. We're going to first figure out where the solution region is. So I'm starting with my first line. I'm telling myself to shade below if you look. So my first line was this one, and it says to shade below. Go all the way. So everything, what we're doing here is everything below this line is false. Like we're getting rid of it. Like this is no longer available to us. If we're in search of the solution, not available to us. Then take the second line. It says to shade above, right? We've determined that. So we line it up there, and we start from one end. And so everything above that line is also not applicable. That's all false. There we go. So far, so as of now, this is our solution region, but we're not done. We have one more inequality, which is the x equals to 4 or -4. We shade to the left, it says, according to our analysis there. So we're going to line it up and shade to the left. It's probably somewhat difficult to see. Can you imagine finding the solution region if we had used regular shading? Like this little triangle should not be shaded right now. That is our solution region, okay? So we're gonna go in there and just go like this. That's the shortcut for solution, SOL with a little n, okay? That's my solution region. Now we're going to determine the POIs, because a lot of students, they get to this part, but then they kind of, the POIs, I'm like, I don't know what to do here, right? And it isn't that difficult if you just apply yourself. Okay, so we're going to grab our calculator, and we've determined that that little triangle there, so by the way, it jives, right? My graph on paper jives with this. That's very important. Okay. So let's go ahead and find these points of intersections here. And if you want to get rid of lines to do this, that's fine. But I'm going to go like this, second trace 5. And see, I'm on the blue line now. So my my first point of intersection that I'm going to try to find is between the red and the blue. So I'm going to select the blue, hit enter, and it already happens to jump to the red one anyways. Select enter again. And if it says guess, you hit enter one more time, and it's -2, 1.5. So let's go ahead and do that. -2, 1.5 is the first one, in no particular order, I must say. Let's do this again. Second trace 5. Now I'm on the blue line again. I want to now get closer to the vertical, the black line there. So that's good enough. I'm going to hit enter, and it jumps to the red. I don't want the red. I want the black line. So just go arrow up or down until you land on the black line. Everything right. So the writing, everything tells you you're now on the black line. You probably won't see your cursor. I don't see it. Let me see. I'm trying to go right to the right to make it show up, but it doesn't. So it doesn't matter. Don't worry about if you don't see the cursor. As long as you know you're on the black line, hit enter. Enter one more time. And there it found it. -4.0, which we already knew, by the way, that was going to be one. One more time. We got to find this one up top here. Second trace 5. Jump to the red line. Keep cycling through until you're on the red line. Everything turns red on your screen. So hit enter. You happen to automatically jump to the black line. Hit enter and enter one more time. That's -4.3. Oops. Go ahead. -4.3. So that's how you find the points of intersection. You don't care about any other ones, no intercepts, nothing like that. I just have to warn you about one thing. Your solution region will not always be a nice triangle. It will not always be. In this case, it was. Can you visualize this with me just real quick? What if I had shaded, instead of to the left of the vertical, we had shaded to the right of the vertical? Then this part right here would have been our solution region. Okay, so you would have only had 2 points of intersection in that case. This one is where it's completely closed in, but it's not always going to be the case. Okay, and you know what? As we practice, you're going to come across that. Next, is -3.1 a solution to the system? I'm going to just do this and then we're done. Unfortunately, you have to use algebra for this. You have to plug this into all of those up there. So 3x is less than 4y minus 12. So you plug in -3 for x, and you plug in 1 for y. And then see if the statement is true. -9 is less than this. Let's do mental math here. This is 4. 4 minus 12 is -8. Is that true? It is true. -9 is less than true. Let's keep going. The next one, 4y. I'm using the original for this one. This is the second inequality that I'm presented with. You have to be careful. The -3 goes in here, and the 1 goes in here. Okay, so 4 times 1 is less than -3 times -3. That's 4 is less than -3 times -3 is +9. That is true. So we keep going. Unless one of them turns false, as soon as one of them is false, the story ends. Like, you don't have to continue. You can automatically conclude it's not a solution. Okay. Next, x is greater than or equal to -4. All you have is x. So you plug in -3 in for x. Is that a true statement? The answer is yes. Right? -3 is bigger than -4. True. Okay. Therefore, -3, 1 is a solution. Let's see here. 1, 2, -3, 1. It's probably just inside the solution region if you look at the diagram itself. So it jives. All right. Homework. You need to practice this. So I would say maybe do 1, 2 inequalities if you need more practice. And then I'm going to say 36 and 37. I'm going to post more, but I will say minimum homework. Can I just say one thing to make your lives a little easier? The POIs are posted at the bottom of this handout of the page. So then you don't need to necessarily check my answer key because this is going to be it, right? But just to keep that in mind, right? Thank you guys. I'll see you tomorrow, Friday.